it's Coach Fred here. I'm going to be going over solving equations with fractions, but we're going to really look at harder examples today. But to do that, we're going to just start with a basic example. When we are looking at equations that have fractions, we certainly can solve them with the fractions in them, but oftentimes it's easier to clear the fractions. We've been working on that a lot this year. So to clear the fractions, we first have to find the lowest common denominator. So in this case, it would be 21. And we multiply that common denominator to every term of the equation. So you can only do this with equations. You cannot do this if it were an expression. I know it's an equation because I have an equal sign and I have an expression equaling an expression. All right, so I'm going to multiply both sides of the equation by 21. Now, whatever I do to one side, I have to do to the other. All right, now, remember, we're multiplying that 21 to the whole equation, so it's actually getting distributed. But once we cancel it with each term, it's going to simplify, and we're going to get rid of the fractions. So I always say to you, 7 goes into 21. How many times? 3. 3 times x would give us 3x. All right, then you move on to the second part. 3 goes into 21 7 times. 7 times x would give me 7x. And then 21 times 10, we love those aren't too hard, would give me 210. All right, now we get 10x equals 210 because we combine the like terms. Then we're going to divide by 10 to isolate the variable. And x would then be 21. Okay, so now these are the kind we've been working with all year up to now. And more terms that we need a denominator for. So first we find the lowest common denominator, which in this case would be 20, and we multiply it to both sides of the equation to clear the fractions. Remember, the goal here is to have no fractions in the second step, like in that second, like when we clear them out, we're going to get rid of them. This is not making the denominators the same. All right, so if we multiply 20 to the first term, we get, let me just show you what's happening, even though we've been practicing it. 20 times 3a over 5, 5 goes into itself once, it goes into 24 times, and then we multiply 4 times 3a, which gives me 12a. If you feel comfortable doing that off to the side, do it. Just don't do it under, keep your equations all together. So do that on the side. All right, then 20 times a over 2 would give me minus 10a. And then the 20s here would cancel to 1, and we'd be left with 1. So then 12a minus 10a gives me 2a. And then isolate the variable by dividing both sides by 2. Giving me a is a half. All right, let's move on to an example with variables that have expressions in them, like this. Now, this concept of clearing fractions is exactly the same. We first find the lowest common denominator, but I want you to pay particular attention to the top because this is an expression that has addition and subtraction. I notice the equation itself has subtraction. So all these things have to be things you notice when you're doing this. All right, so my lowest common denominator is 15. All right, so I'm going to multiply both sides by 15. Both sides by 15. All right, now 3 goes into 15 5 times, giving me 5x for the first term. 5 goes into 15 3 times, which gives me 3 times x plus 2. And then 2 times 15 gives me 30. Now, why did I do that? Well, because if I multiplied 3 times x plus 2 and I didn't put parentheses around it, I might forget that that 3 has to be multiplied to the entire quantity. Additionally, there's a subtraction sign in front of it, so I actually have to multiply a negative 3 through the x plus 2, that quantity. So I want to be really careful, especially right there. All right, so I'm going to distribute my negative 3, and then I'm going to simplify the left by combining like terms. So 2x minus 6 equals 30. Now I'm ready to solve the equation by isolating the variable. So we're going to add 6. So 2x equals 36, and so x equals 18. All right, now remember, if I take 18 and I plug it in for x, I'm going to get an expression that makes it equal to 2. So let's test that out. I want to show you. 18 over 3 minus 18 plus 2 over 5, does that equal 2? So let's see. 18 over 3 is 6, minus 18 plus 2 is 20 over 5, which is 4. It does indeed equal 2, so 2 equals 2, making a true equation. All right, let's look at a couple more. All right, I'm going to have you try this one on your own, and let's see what we come up with. And now we're going to look at ones that don't have numbers as denominators, but have expressions. This is where finding the common denominator can get a little tricky. Now, you have to look at every factor, and an expression is its own factor. So in this case, 3 minus x is a factor, and so it is a denominator. It is part of my denominator. So when I multiply both sides by the lowest common denominator, in this case, my lowest common denominator would be 9 times 3 minus x, okay? Now I know that's kind of confusing, but that's going to be our lowest common denominator. Every factor, most times it occurs. Okay, so I'm going to multiply both sides by 9 times 3 minus x and 9 times 3 minus x. All right, again, clearing the fractions. So now the 3 minus x on this side cancel, and I have 9 times 2 minus x. And the 9's cancel over on this side, so we're left with 4 times 3 minus x. All right, now we got to do some work. So we distribute on both sides, which means multiply. So we get 18 minus 9x equals 12 minus 4x. All right, then we solve and isolate the variables. So I'm going to actually bring the 9x to the other side because I was like bringing the smaller one over to make it positive. I'm going to subtract 12. All right, that gives me 6 equals, what is that, 5x? And then I'm going to divide both sides by 5. So x equals 6/5. One thing I almost forgot, and I want to go back to the original for a second. In class this week, we talked a lot about the denominator of a fraction, that we can never get a 0 in the denominator. So when we do have an equation that has a variable in the denominator, actually step 1 should really be write down your restricted value. That way, if you get that as an answer, you know it can't work. So in this case, if x was 3, we'd get 3 minus 3, which would give me an expression with 0 in the denominator. So x cannot equal 3. So we want to do that first, okay? So I forgot to mention that. All right, let's look at the last one. The last one, best one, hardest one, okay? So in this example, my lowest common denominator, it could be kind of confusing. My lowest common denominator would be b times b minus 1 because b is a factor and b minus 1 is a factor. All right, now going back to that, what I just showed you, I want to write down my restricted values. Value or values, in this case it's values. My restricted values here would be that b cannot equal 0 because if b were 0, then the denominator on this first term would be 0. And b cannot equal 1 because if b is 1, then 1 minus 1 gives me 0, making the denominator 0. All right, so if we get an answer of 1 or 0, it can't be our answer. So we'd have to throw that answer out. All right, I'm going to get that out of the way now. You should have it in your notes. All right, so now I'm going to multiply this entire equation by b times b minus 1 and b times b minus 1. Now, you might notice that in the first term, the b and the b minus 1 cancel, just leaving me with 2. All right, in the second part, the b minus 1's cancel, and that's going to leave me with 2b. On the left side, nothing cancels, so I'm going to be left with b times b minus 1. All right, so we have an equation. No fractions left, so it's much better. But remember, equations are expressions equaling expressions, and so we simplify first, then we balance. So I'm going to simplify by multiplying on this side. So we get b squared minus b equals 2 minus 2b. I now notice that the equation is quadratic, so I'm going to try to solve by factoring, but in order to do that, I have to get the equation set equal to 0 in standard form. So that means in the form ax squared plus bx plus c equals 0. All right, so I want b squared to be positive. It's easier when it is, so I'm going to bring the 2b to the other side, and I'm going to also subtract the 2. Okay, so that's going to leave me with 0 equals b squared plus b minus 2. Now I'm going to try and factor this. So remember, when we factor, it means we're breaking it up with multiplication. We want the factors of a negative 2 that add to 1. So that would be 2 and 1. So what is that? Positive 2 and negative 1. Now, we're not done because we have to solve, so we're going to use the zero product property. So we're going to set each factor equal to 0 and solve for that value. So we get b equals 1 and b equals negative 2. All right, now we got to go back and think about our restricted value. Our restricted value, we said b could not be 1. So this answer actually has to get thrown out. So my answer would be b equals negative 2. All right, guys, I know that was a little bit of a longer video, but hopefully it was helpful. Now, I want to remind you, you can always go back and rewind anything that you didn't understand. And this is going to be one of those videos that I think you might have to do that. Have a great day. Bye.